All right, so here we are to talk a little bit about chemical reactions. Let's move that guy a little bit out of the way. Well, maybe. There we go. All right, so the first thing is I can identify the parts of a chemical reaction. So I just came up with a very basic chemical reaction down here. Hydrochloric acid plus sodium hydroxide gives you table salt and water. And so all you have to do for biology, because we're not chemistry, is you have to identify that these are the reactants and these are the products. And this arrow stands for yields or the actual reaction itself. So it's the bim bam boom of what's actually happening to get from the reactants to the products, the breaking of bonds, the reforming of bonds, all that good stuff. So that's all you really need to know for the parts of a chemical reaction. The second I can for this is I can give the reactants and products for a dehydration synthesis reaction. And so here we have a dehydration synthesis reaction. And all that you have to know here is that you have some monomer plus another monomer of the same kind. So this could be an amino acid plus an amino acid, or a monosaccharide and a monosaccharide. And they are going to form a polymer. And when they do that, they're going to lose a water. Okay. Easiest way to show this is with an amino acid. So I'll draw one of those really quickly. Should have drawn it beforehand. And another amino acid. And what happens when you have two monomers coming together is, so you've got your amino group over here and your carboxyl. This OH and this H are going to come off. That's what's going to form your water, and that's going to free up this bond here on the carbon and this bond here on the nitrogen, so they can then form a bond to join together. Sorry, I didn't mean to just flip you all over the place there, but I wanted to grab a highlighter. So that would be where that water is coming from. So monomer plus monomer leads to a polymer. If this was amino acid, this would be a protein. If it was monosaccharide, it would be a carb. If it was nucleotide, would be a nucleic acid. But when they come together, you lose a water. If you joined 3 monomers together, you would lose 2 waters, because every time 2 monomers join, a water is lost. Hydrolysis is just the reverse. You start with your polymer, and you are then going to break it into your monomer and your monomer. So again, if this was a carb, you'd be breaking it into 2 monosaccharides. The reverse of what we showed down here is going to happen. In this case, this bond is already formed. We're going to need to break that bond. We're going to need to take a water, add it in, but we need to blow it up. So we're going to blow that water into an OH and an H. And one of these monomers will get the OH, and one of them will get the H. And that will refill those bonds that when we broke the bond between the C and the N, it gives that OH back to the C and that H back to the N. And so that is where that water gets split. Lysis means to break or burst. And water, hydro means water, so that's where the name technically comes from. We're breaking water so that we can give it to those 2 monomers. The last thing is to compare and contrast hydrolysis and dehydration synthesis. Contrasting, they're opposites. Dehydration synthesis starts with monomers and ends with a polymer. Hydrolysis starts with a polymer and ends with a monomer. Starts with simple items and makes a complex one. Starts with a complex one and makes a simple one. Energy is stored. Energy is released because you're breaking that bond. Water is formed. Water is used. So those are some of the differences or the contrast. For compare, these are both chemical reactions. They both involve reactants and products. They both involve water. They both involve monomers and polymers. So there's a lot of little similarities there as well. So I hope that helps. If you have any questions, let me know and we can go over it some more.